So, hi everybody, thank you for coming. My name is Marta Rivera. This talk will be in English because I sent the abstract like that. But the questions can be in Spanish. If you prefer, it doesn't really matter to me. So today I'm here to talk to you about the work we have been doing at Clarity. I'm going to tell you about 3 side projects we have been working on, analyzing the data set that we use to compute social impact to run companies. That's the core of Clarity. And these 3 side projects are 3 papers that we have presented this summer, and with we, I mean me and those 2 guys there on the front row. So actually, if you have specific questions about some of these, about the details of part of this work, I maybe point to them, but they are my backup here today. So first of all, who am I? So I always use this slide as an introduction to myself, and people like to introduce themselves with this timeline, very organized, like I first studied this. For me, being where I am right now, talking to you about economy is just a random walk, very crazy random walk. And that's why I like this slide to be all over the place. I'm a physicist by training. I have a PhD in neuroscience. I have been working on computer vision for more years than I'm going to confess. And I have been working in finance and economy for the last 3 years, when I left academia and I decided to move back to Spain. I also keep teaching in the university in Madrid because I love it. And I teach statistics, and I never took a class of statistics in my life. And I teach data science, and I never took a class in data science in my life. So again, this is all over the place. I'm an outsider everywhere. I have been an outsider since day 1. So I'm going to apologize to all the economists in the room right now, that I know there are at least 3, for all the wrong things that I'm going to say, but let's give up. So I told you that I work now at Clarity as a lead data scientist. What the hell do we do at Clarity? So at Clarity, we believe that capitalism is broken, and I love to say this sentence in talks. So capitalism is broken because it's leaving many people behind. It's just investing on things, on products to make you richer, but not to make society better. And we think we can change that, or we can start making the change towards that by providing the right information to the right stakeholders. So what we develop is impact metrics, environmental metrics, social metrics, to really allow investors to put their money where it matters the most, to us, to society, and to everyone that is really putting the money on the table, because at the end of the day, part of the investment is done with your money, it's done with your pension funds, it's done with your personal deposits. And you really care, I believe, I hope, you really care where that money is coming from. You just don't want to make more money out of people suffering, right? So this whole field of sustainable investment is growing a lot. We want to make our part of that by providing more precise, more specific data sets, so investors can make the best out of our money and your money. So what we do, as I mentioned, we develop ESG metrics. This ESG stands for environmental, social, and governance. And these are some examples here. The traditional ESG framework measures how companies behave. In general, we develop those metrics too. But today, I'm going to focus a little bit of the work we do every day, the 3 of us actually, that is more oriented towards what companies are producing and to whom they are serving that. So we believe that the traditional ESG framework is just measuring the how. And we believe there is a missing dimension, then there is the what. Basically what we do, and I will explain you in a second, is try to allocate the part of the I was going to say the blame, but part of the contribution to from each company to everything that you buy, that you consume, or everything that is fulfilling your needs in general, also the governments, of course. Okay, so why in the universe we actually need these two ratings? I have an example here with Gucci and Walmart, but I tend to use an example with Rolex, and at some point I think they are going to sue me because I make this example too often. So imagine that you want to invest in a company with a great behavior, and you could think of Rolex. Rolex is a great company. Their production system is very environmental friendly. I mean, they make watches. And they pay their employees a lot because they are in Switzerland, and they have very nice social programs. They have a specific program to support poor children in Zurich. They choose poor children in Zurich, that must be. And the thing is that if you really, really want to make an impact on society and you invest in Rolex, you are at the end of the day contributed to make luxury watches. So if you really want to impact what people are doing every day, maybe you want to invest in a water company in Brazil. Of course, once you have two water companies in Brazil, you will pick the one that is more sustainable, that for sure. But we want to make that computation to make possible for investors and for you to invest in those companies that are providing the most to society as a whole. Not only to your return, not even only at that environmental point of view. Of course, in perfect combination with that. I'm not saying you should pollute, don't take me wrong. So how the hell we compute that society score that we call? So we combine a lot of consumption data, and these are the data that I'm going to focus on in our side cases, but I just wanted to give you an overview of what we actually do in our daily basis, not only side projects, we also have a core. So we combine all those consumption data, we allocate, we compute what are the budget shares that you allocate to each of these, to the companies and to the governments that provide you services. We move those points through the whole value chains of products and services, so we can give also scores to companies that are not directly serving you. And I can think on transportation companies or the electrical companies, right? And then we combine that with the dollars that each of those companies spend to produce those goods and services, and we compute what we call the society score, that at the end of the day is a ranking. But because most of you are not investors or not full-size investors, if you are, let me know. We can talk, I can show you our tool. I'm gonna explain you a little bit more about our side projects. They are more fun from a scientific and data scientist point of view. But if you have any questions about that, we are happy to reply. So the side projects that I'm gonna tell you about are about two of these consumption data providers. The first one is a popular personal finance manager in Spain, whose name I'm not allowed to reveal. Do you guys know what a personal finance manager is? It's basically an app in your phone that aggregates your bank accounts and tells you that you are spending too much money on shoes, for example. So those guys are selling us their data set, of course GDPR compliant. I don't know, we don't know who these persons are, and we don't want to know. This is very clear, it's impossible for us to track these people back. I just want to clarify this. I'm a full fan of GDPR compliant, because it really makes my life way easier if I don't know who you are. So basically, this data set includes 50,000 anonymized users from Spain for several years, actually. They include some demographic information at the detail of the Comunidad Autónoma, okay, autonomous region, and an income range, gender, age range, things like that. Again, impossible for me to track you back. And we also can allocate, we can connect the consumption to different consumption categories. They could be things like rents and mortgages, or restaurants, or clothing, okay? So the first side project that I'm gonna tell you about is related to something that is called manifold learning. Yes? That the information is the correct one? What do you mean? Yes? Okay, so I trust my provider till a level. We do a lot of quality checks on everything that we receive because data can be noisy. And we don't trust it completely because sometimes we have the vendor, not only the category, so we can track back and reorganize that categorization. And I think I know why you are saying this, but so we track back the vendor, we correct some of the categories. If for some of the cases, we know that the price is wrong, like it's impossible for you to have spent that much money in that thing, on that specific category, like thousands of dollars on shoes. It's like, yeah, this person has a problem, or these were not shoes, right? So we trace back. Like for companies like Amazon, we cannot recategorize because they sell everything, but for companies, smaller companies, we can. Like Netflix, for example, we have miscategorizations in Netflix, we correct those. Like data quality and data check is our nightmare. Is the nightmare. Like when we talk about data cleaning, in general in data science, it's not only about outliers, it's about these kinds of things too. It's like this. Like, yeah, we do that, we fight against those things. And I think maybe I have your data then. Anyhow, so I was saying that we use these 50,000 people, and we were trying to understand a bit better what were their consumption profiles. Okay, consumption profiles is basically the overall distribution of our users' total income. Okay, that's what we call consumption profiles. So we were plotting things, and things can get very messy very quickly. So this is the kind of a FIFA plot. If you have played FIFA, you know what I'm talking about. This is. Should I explain it, or is that necessary completely? So these are the relative consumption of the mean population in our sample, okay? It's not representative of the Spanish population, it's not representative of our sample. There are a lot of people, but there are still not. Like, we don't have women over 50 in La Rioja, for example. So that is not represented in our sample, in this case. So they spend 7% of the money on food. This is just a subsample of categories, so I can show them to you relatively nicely. And this is just the mean of our distribution. You could say, okay, this is the consumption profile of Spain. You will be wrong, 100%. It's not even the consumption profile of our sample, because if you already start splitting by age, we see that these consumption profiles diverge, okay? Yes? Sorry? These are restaurants. Okay? Okay, so I'm getting questions. This is interesting. So people around in their 20s are consuming a lot of recreation and restaurants and clothing and some transportation. That is basically the public transportation. And people around 60, they spend most of the money on food and phone. This is, I guess, is Telefónica's fault somehow. But still, so we start seeing some diversity already by the categories that we have. But something that is very interesting here is this other example. So we have here 4 different individuals. There are all of them from the same area. I think they were from Madrid, in their 40s, around the same in the same income range, and they were all guys. And you can see how their consumption profiles diverge diametrically. So the thing is, when we want to characterize the behavior of these people, does it make sense for us to use the traditional categorizations? That is actually an input for us. It's part of our data set. When we are trying to better serve this person that spends just 25% of his salary, these are guys all, on housing, is the same one that this guy that is just going to hotels all day long? Or this other guy that is spending all his money on education and food, right? These profiles are very different, and we were wondering if it really made sense for us to do this categorization, or we can go one step further and let us, the data, know which are more meaningful groups of people. So for that, we use this technique called TSNE, that is an algorithm of manifold learning. Long story short, this is complicated, but bear with me. So our consumption profiles are 27-dimensional vectors. That's something that you cannot represent on a screen. If at any point in time anybody tells you, oh no, I can visualize 27 dimensions, no problem, don't believe that person. That is not possible. So the trick that we do here is an embedding. This is not a projection, it's not a linear projection of our 27-dimensional space, it's actually a non-linear modification of that space that allows us to see every single point in 2 dimensions. Each point here is a user. There are 50,000 people in this plot, okay? But these 2 dimensions, the price that we pay to be able to represent that is that these 2 dimensions don't really mean anything, okay? We cannot go back and track back how those dimensions were built, okay? But we can see everybody. That is the trade-off always that we have with supervised and unsupervised and these kinds of embeddings. If you're interested on the topic, the general theory is called manifold learning, and this is one of many of those algorithms. It's my favorite, and it's called TSNE. It's included in scikit-learn already, so you can just use scikit-learn TSNE wait. It's not super fast. And then you will get this. In this example, what we have colored each of the individuals by the monthly income. Okay, so the more yellow the dot, the higher the income. We have an island here of very rich people, and we have areas here of less wealthy people, some corner there were less wealthy people. Here we have half and half in this other island, okay? TSNE is an stochastic algorithm. If you run it several times, it will give you slightly different answers. The key here, what you have to take into consideration, like the close distances are meaningful, the long distances are not. So don't try to make interpretations of these guys are farther from those guys than this other one, because that doesn't hold true, okay? That's not what TSNE is trying to do. Other manifold learners do, but not these guys. Okay, so why is then this useful? But because I told you that each of these points are a person, we can go back and represent the same way we were doing with income, every single of our vectors back onto the TSNE. So in this case, we were saying that these people up here, they have low income, they spend a lot of money on recreation, they are, no, this is another corner. Okay, these other people spend a lot of money on housing, and they are middle-aged. Okay, so we have just identified 2 different groups of people by the consumption. Okay, directly, because they are placed in different parts of this plot, and I can prove to you that there are actually the consumption profiles are actually very extreme and very different. Okay, these people here are actually diverse. They are in the center age, but they still have some, this is the one for housing specifically, yeah, the housing group, and they have lower income than the mean, and this is the case for recreation. So in the housing group, if we would have split these people just by their age, we wouldn't be able to reconstruct this group, right? Because we have young people and we have very old people, all of them there. And we have, in the case of recreation, we have low-income people and some few of rich people, okay? So we use this to recreate those behavior groups instead of the demographic groups. Okay, I hope it made sense somehow. The second side project that I wanted to tell you about is slightly different, but I use the same data set for this. So in this case, and this is something that never happens, I have no idea how it happened to me actually. It was Christmas last year, and I was at my parents' house. I'm from Segovia, by the way. And I was reading some papers because I wanted to do one of these side projects, and I came across a paper about complexity of countries by a guy called César Hidalgo, a very good friend of mine now, not really. And And the thing is, this guy was saying that countries are more complex when their exportation repertoire is more diverse. And he had a whole theory about that, and he was also telling how products are more complex and more sophisticated when more countries were exporting and importing them. And he has a whole theory about economic complexity and how richer countries are more complex and things like that. And while I was reading that paper, I came across one of the figures that I'm going to show you in a second, and I realized that we had the same thing. That we could analyze consumption also as a complexity network. And what I was able to do at the end, I'm going to go through the details, was to reconstruct this hierarchy of the needs of the categories, okay? Of the consumption categories, and based on the sophistication. Okay, start from the beginning. What the hell is a hierarchy of needs? So Maslow, very smart guy, many years ago made the theory that needs for humans are actually organized in a hierarchy, that you start feeling the hierarchy from bottom up, and you first try to get food, to get shelter, to be, and to drink. Okay, those are the categories that he called physiological needs. Once you are fine with these physiological needs, you start satisfying safety needs like security. Then belongings and love. You start liking people, I guess. Self-esteem, and finally some self-actualizations. There is a huge debate in social sciences about where sex goes in this category. That's so you know. You can read people about discussing whether sex is something organic or emotional, or it's amazing. But for me, it's just a reference to explain you what I mean with hierarchy of needs. Of course, I cannot be self-actualization and self-esteem on our consumption data. It's very hard to make that connection, or at least I'm not brave enough to make that connection, so I'm pretty sure people will be able to do that. I'm still a physicist, okay? So I have sometimes problems with those things. So I was saying that we have this complexity of needs, this sophistication of needs that will be organized like this, and I know these guys are upside down, it's not a mistake in my slide. But this serves me to make sure that I explain you something important here. So if you think about it, physiological needs are fulfilled by every single member of the population. It doesn't matter where they are in the pyramid of Egyptians, okay? Both the rich and the poor people have to drink and get shelter, okay? So that means that these guys are affecting, the basic needs are affecting everybody in the pyramid. The same is true for the rich, the pharaoh here. So the pharaoh here, I put it here at the bottom. I put it here at the bottom because that guy is actually consuming all possible categories. Okay? You see what I mean here? So the poor people only consume a few categories. The very expensive categories are only consumed by a few people. Okay, that's why I inverted the other one, so you get that intuition that the richer, the more categories, the poorer, the less categories, the most basic, the more diverse people, the more luxurious, the less diversification of people, and that's why I inverted these two things. And if this concept is clear just with this slide, I'm very happy today. So I told you a second ago that I was reading a paper about complexity, and I realized that we could analyze the data the same way. And it was from this plot. So I didn't mention it. This is a Python conference. Everything that I'm saying I did in Python, just in case. So this is a Python plot you can recognize because the color code is the Viridis default color code. So basically what we have here, we have the income segments organized. This is the same data set we were talking about before. This is Spain. So we have the low-income people, high-income people, and we have the consumption categories. As I mentioned, it could be food, clothing, house repairs, blah, blah. And this is the percentage of consumers for each of these categories that we find in each of those income segments, okay? So the higher the color, that means that people making almost 6,000 euros a month, whoever they are consuming very often from all those categories. And that is exactly the point that I was making in my previous slide, right? The richer you are, the more diverse is your consumption. Okay? I ordered this plot by consumption income, but if we actually do the whole theory and apply all the mathematical parts, you reconstruct the same plot, showing you that the higher the income, the most sophisticated you are, the more basic the category, the less complex it is. Okay, so there is a lot of mathematical work I didn't want to bother you with, but I can if you wish. And basically an optimization of a transformation of this matrix. And what did I get at the end? First, the thing that the richer, the more complex, and I was, yes. Yes, give me a second. I'm doing right now. So I was telling you that we can reconstruct then the hierarchy of needs, that basically the higher you are in this representation now, the less income groups consume you, it makes you more complex, okay, more luxurious. Okay, so categories that everybody consumes in our data set are cash. It's a false category, but I just want to keep my quality checks. Food, restaurant, clothing, personal transport, recreation, electronics, public transportation. Things got more fancy. Here we have health, phone, household appliances. You go up, 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 and at the end on the top of the pyramid you have rent and mortgages. I'm not saying that the Spanish population is homeless. I'm lucky enough that I know this country somehow, and I know that it's not true for a fact. What this data set, what this result is telling us though, is that many people that even though they have an income, they are not paying for their own houses. They are not, I mean, if you read the literature about that, as I did, because I was as surprised as you are about this, that is true. People are not really being able to afford this. There is also a component here, but it's not affecting a lot our data set because I don't have those people in my data set. There are old people that are already paid for their house. Okay, but they are not really messing up my calculations because I don't see them in any case. They are not part of the data set. Yes?
You said that people are sharing houses often, so not everybody is paying rent. Maybe one is paying for 2 or 3 or 4 people.
Yeah, so that is a good point. Still, we have a way of recognizing whether you have a recurrent, and if basically in your app, if you code it as rent, I will see it as rent. I will see it as rent. So yes and no. Of course, we are missing part of the data, but not fully. Yes. So that is way over the data that I have in my data set. I did my research. Again, I'm not a social scientist, or I am, I don't know anymore. That is not the hypothesis, that is what the National Institute of Statistics is saying. So it's, yes, people are living with their parents. In Spain, in the 21st century, is this crazy. People with a salary. Okay, and the last side project I wanted to tell you about is actually about a different data set that we have from small convenience stores in Mexico. Our provider in this case is this company called FrogTech. They let me tell you their name. And these guys are doing something super cool that is basically placing iPads in a small convenience store all over Mexico. So the cash, because in Mexico people pay with cash still, and more every day actually, can be tracked. Okay, can be tracked for the store itself and for everybody else trying to understand what the hell these people are consuming, not only to do marketing but also to help them. This is part of the government effort actually. So this data set is huge. We have 62 million transactions. Okay, in this case we don't have personal data. We have store data for almost 2,000 stores, and we have granularity till the minute. Okay, we have 2 liters Coca-Cola was sent in this super small store in this area. We actually have the area combined, and we have the socioeconomic status here. The socioeconomic status by location of the store, with a very fun work we had to do about how many trucks they had in the neighborhood. It was fun. This is an official, actually, it's an official classification of socioeconomic status that they do in Mexico. Apparently it's important to know how many trucks you have. So this data set, basically this is a summary, so you can see that we have data from many different states across all Mexico. We have many transactions, and our data is slightly biased toward Valle de Mexico. There is also very important hub of population. We have high, medium, and low socioeconomic segments. And I have to go one slide back to explain you something first. So what we did here is we tested Angus Deaton theory about the Engel curves. Angus Deaton won a Nobel Prize for this. Engel is Engel. We know him. He's all over the place. So Angus Deaton used the Engel curves that are basically curves like this. This is your income, so the more money you make, these curves are measuring how your relative spend on a given product changes, okay? That's the Engel curve. And Angus Deaton said, okay, if this curve has this shape, okay, that is because that is a basic need, that is a necessity good, and it has this shape, it's a luxury good. That's all what you need to know. That is basically a parameter that is smaller or larger than 0. Okay? Sorry, than 1. And that's all what we need to do. So we were able to combine this huge data set, and with some math that we will be happy to share with you if you want, we were able to compute this. This is for 4 consumption categories, in this case food, non-alcoholic beverage, alcoholic beverage, and cigarette. We were able to prove that both beverage, these are alcoholic and non-alcoholic beverage are actually luxuries for Mexico, and food and cigarettes are basic needs. Yeah, I didn't make it up, okay? It's what the data said. Don't kill me. This is just the calculation that we did. Is actually supported from the literature. I think it's funny that cigarettes are basic needs. They are very addictive. I wouldn't be surprised that is the case. So, okay. And I actually missed a joke. I think I have 2 more minutes. I missed 1 more minute. I missed a joke that I always make. This is the budget share across these 4 categories. We aggregated the data by the day of the week. And the alcoholic beverage is in blue. I think you don't need me to interpret this plot for you. This is one of the validations we do to make sure our data makes sense. Our data makes sense. People tend to drink more on Fridays, Saturdays, and Sundays. They don't stop drinking on Mondays, just so you know. But this data makes sense, so we're still confident that our results make sense too. So the last thing that I wanted to share with you, so if this thing wants to move, was how cool we are and how many tools we actually use, not only in the data science team, but also in the tech team, because, oh, surprise, we are hiring. So I'm happy to talk to any of you now in the coffee break. If you need my contacts, I have some cards too, and you can come to talk to us whenever you want. Thank you very much.
Couple of questions, okay.
Hi, I like the vision of your company, and I think you have a lot of merit because I saw you yesterday dancing in the PyCon party. Thank you for the tag. It has been very nice. I have 2 questions. What kind of data scientists are you looking for? Because as I understand, you need like ethical knowledge to evaluate this kind of analysis, right? A normal technical, you need more than that. How do you evaluate that skills? And another question is, do you have in the company people from social science with maybe less technical knowledge?
Can you hear me? No? Yes? Yes, now. So, no? data scientist, but I'm not. So we actually, I mean, that first question is about cultural fit. We have cultural fit interviews like everybody else. I expect everybody to have high ethical standards in general, not only to be in my team, right? So in that sense, of course, if you don't care about environment, you won't be aligned, or to environment or to society, you won't be aligned with with Clarity's mission. But I'm not entirely sure if I want you in my team in any case. So, I mean, sure, we have a cultural fit interview like you, most probably. And we want people to be aligned with our values, but that doesn't need because I think people should be aligned with those general values of being better to the world always. And what was the second question? I missed it. Yeah. So I didn't say it, but we have, in the data science team, we are 12 people currently, but the research team, there are 8 people. And they are less technical programming, more technical in environment, in economy in general. So we work together very closely, actually, because we give them a lot of support. We do a lot of those side projects, but they are more the economists and the social environmental scientists and things like that. So we interact with that core. We are not alone. Yeah. More questions?
Okay, thanks for the talk. It was super interesting. And I saw you said in a slide that you're managing externalities. I'm an environmental engineer myself, so how do you manage externalities? Because environment, social stuff have a lot of value, but they're not normally measured. How do you do that in the company?
So in that, can you hear me or not? Now. So we have, I don't know, hundreds of models transforming from raw metrics to actual impact. So measuring impact in a financial way has been done many times. We are not reinventing the wheel. We are just aggregating the wheel, basically. But in that specific case, those externalities were super specific to things that can kill you directly, and I shouldn't give credit to the products you bought to fulfill your needs. There are things like obesity or gambling. They were very specific to that consumption data set. But yeah, so we are measuring systematically what is the cost in lives, what is the cost in your life, in everybody's life, for the whole economy, that we are polluting, that companies are not paying well, that all those kinds of things. Those are econometric models. They are very standard and very contradictory to each other. That's why our research team is 10 people at this point. We are 60 and we have people analyzing those models at that rate. Any more questions then? Okay, thank you very much.